Good day and welcome to another video. So in today's video, we're going to be discussing a question on chemical equilibrium. This is a part 2 video. If you haven't seen a previous video on chemical equilibrium, please go and check that out. It should be out already. In today's question, we're going to be looking at the 2023 mock exam, question 6, which is the chemical equilibrium question. So let's take a read at what it says. So question 6 says, hydrogen gas is prepared by the reaction of methane, and steam, and is shown in the balanced chemical equation. So we can see the chemical equation there, drawn for us. And then we can also see that the change in enthalpy is positive 260 kilojoules, right? So what does that mean for us? So whenever we have a change in enthalpy that is greater than 0, that tells us that the forward reaction is endothermic. While the reverse reaction is exothermic. Alright, so whenever change in enthalpy is positive, that means the forward is endothermic and the reverse is exothermic. Further on, we're told that methane and steam are sealed in a 2 decimeter container to react and are allowed to reach equilibrium at a temperature of T. 6.1 then asks us to state Le Chatelier's principle. So I've gone ahead and written it for us already. So it just simply states that when the equilibrium in a closed system is disturbed, that system will reinstate a new equilibrium by favoring the reaction. So it can either favor the forward reaction or the reverse reaction that opposes that change. 6.2 then is asking us to use Le Chatelier's principle to explain how the following changes will affect the yield of hydrogen gas, right? So we've got the chemical reaction there. So let's maybe rewrite that chemical equation. So there is our chemical reaction. And then we're asked what would happen to the yield of hydrogen gas, so 6.2.1, when adding more of CH4, right? So when you add more of CH4, right, what is going to happen? The first thing that's going to happen is that the concentration of CH4, so the square brackets means concentration, and then concentration of CH4 will increase when you increase the concentration of CH4. What then happens is the system will now try to decrease the concentration of CH4. It does that by favoring the forward reaction. So when you increase the concentration of CH4, the forward reaction is what uses up that increase in the concentration. So therefore the forward reaction will be favored. The forward reaction will be favored. And therefore, if the forward reaction is favored, you're going to form more of hydrogen gas. So therefore, more, or rather we should say the yield, which is just the amount of hydrogen gas, will increase. Wonderful. Six point 2.2 is asking us what will happen to the yield of hydrogen gas when you decrease the volume of the container. So now, when you decrease the volume, so a couple of things happen, right? So there is a inversely proportional relationship between volume and pressure. So what does that mean? That means when the volume increases, the pressure decreases, all right? And when volume decreases, the pressure increases, okay? So because you decrease the volume, what's going to happen to the pressure? The pressure will increase. So the pressure, we say pressure will increase, all right? And an increase in pressure, therefore, according to Le Chatelier's principle, therefore favors the reaction that produces fewer number of moles of gas. So that's according to Le Chatelier's principle, that an increase in pressure will favor the reaction that produces fewer number of moles of gas. Okay, so how do we know that? How can we figure that out? So it's quite simple, really. So when we look at the forward reaction, right? So the forward reaction produces two gases, carbon dioxide gas and hydrogen gas. So you've got 1 mole of carbon dioxide gas plus 3 moles of hydrogen gas. So therefore the forward reaction will produce 4 moles in total of gas. That's the forward reaction. The reverse reaction, the reverse reaction is in the opposite direction. So in that direction, that produces, you've got 1 mole of hydrogen gas and 1 mole of methane gas. So therefore in total, you've got 2 moles of gas that is produced by the reverse reaction. So remember, Le Chatelier's principle tells us that an increase in pressure will favor the reaction that produces fewer, the keyword there, produces fewer number of moles of gas. So the reverse reaction, as we've seen here, produces fewer number of moles of gas. So therefore the reverse reaction will be favored. And because the reverse reaction is favored, the reverse reaction uses up the yield of hydrogen gas. Because when you go in this direction, these become your reactants and this becomes your products. So your hydrogen gas will be used up. So therefore we say the yield of hydrogen gas will decrease. Wonderful. Now, the next question reads, the sketch graph below shows the changes in the number of moles of methane, steam, carbon monoxide, as the reaction proceeds in the preparation of hydrogen gas in a 2 decimeter cube container. So this is a number of moles versus time graph. So if you can just take a look here, carbon dioxide and hydrogen gas are my products. I know that because at time 0 I had none of them. There was nothing, and then over time they increased. And vice versa, my H2O, which is my steam, and my methane are my reactants, and I can tell that because at time 0 you had a pretty high number of moles of methane and steam, and over time they are decreasing, as we can see over there. Wonderful. Then 6.3 asks us to write down a reason why there is no change in the number of moles of each of the gases between T1 and T2. So at T1, the simple answer to this is equilibrium is established, okay? Because it tells us that when equilibrium is, we know that Le Chatelier's principle tells us that when equilibrium is established, there is no more change in the concentration of the reactants or products. So simply to answer that question, to 6.3, we can say simply that chemical equilibrium, some like to say dynamic equilibrium, has been reached. All right. Another way you could say that the rate of the forward and the rate of the reverse reaction is the same, because that's what chemical equilibrium is, when the rate of the forward reaction is equal to the rate of the reverse reaction. One and the same thing. Wonderful. 6.4 then asks us to use the information in the graph to calculate the equilibrium constant Kc for this reaction at T. So this is quite useful because at time 0, we know exactly how much we have of our reactants and of our products. And then we also know that when equilibrium is reached, we know, this at T1, we know the amount of carbon monoxide that is at equilibrium. So we can use all these values to calculate the Kc. So to do this, we're going to set up our Rice C table and kickstart from there. So first off, we always wanna write our balanced chemical reaction. Just make sure I do the right thing, and 3. Then it's balanced. All right. So I've got 1 carbon on the left, 1 carbon on the right. So I've got 1 carbon on the left, 1 carbon on the right. I've got 4 plus 2 hydrogens, so 6 hydrogens. And then on the right, I've got 6 hydrogens. I've got 1 oxygen on the left, 1 oxygen on the right. So therefore, this reaction is balanced. So always check, right? So always check that this is balanced. All right. Then you can set up your Rice C table. So when we write our chemical ratio, so remember R stands for ratio. So this is 1, hydrogen is 1, carbon dioxide is 1, and hydrogen gas is 3. Our initial number of moles, so therefore we can go straight to this graph. So if you want to test it out for yourself, please feel free to pause the video here and then try it out on your own, and then you can unpause it to see if we get the same answer. So if we continue at time 0, what do we have initially for methane and the steam? So methane have 1.4 moles, remember this number of moles, and then for steam I've got 1.2, and then for my products, carbon monoxide, and hydrogen gas, I've got 0, 0, because at time 0 I've got no products. Then I know that at equilibrium I form 0.6 moles of carbon monoxide. So what does that mean? That means at equilibrium, carbon monoxide, I've got 0.6. So what does that mean for my change? That means for my change, I gained 0.6 moles. So this is plus 0.6 moles, right? And because this is a 1-to-1 ratio here, so that means this will also be 0.6 and this will also be 0.6. Remember, the ratio is used on the change column or the change row. And remember, reactants are being used up and products are being formed. And therefore, how do we now figure out what is the change for the hydrogen gas? So there's a 1:3 relationship, right? So 1:3, that means we divide this 0.6 by 3, and therefore we'll get 0.2. And that means we increased here by 0.2. So that means at equilibrium, 0 plus 0.2, that will give us 0.2 moles of hydrogen gas. For my steam, 1.2 minus 0.6, that will give me 0.6 moles of steam at equilibrium. And therefore, for my methane gas, I've got 1.4 minus 0.6, and therefore I've got 0.8 moles at equilibrium. And now remember, the C is concentration, so that's number of moles divided by volume. And remember, we're going to divide everything here by 2 because that is the volume of this container. So I've got 0.8 divided by 2. This will give me 0.4. I've got 0.6 divided by 2. This will give me 0.3. I've got 0.6 divided by 2. This will give me 0.3. I've got 0.2 divided by 2. This will give me 0.1. So all of these values in blue are now my concentrations when equilibrium is reached. Now that I have my concentrations, I can now set up my Kc equation. So let's just copy our equation here and paste it here. So we can continue, just remove these columns. And now we can set up our Kc expression. So Kc, remember, is equal to the concentration of the products. So my products, I've got carbon monoxide, 1 mole of carbon monoxide, and 3 moles of hydrogen gas. So this is to the power 3, divided by my reactants, which is C4, methane, and hydrogen gas. 1 mole of hydrogen gas and 1 mole of methane. And now I can substitute my values. So for carbon monoxide, I've got 0.3. For hydrogen gas, I've got 0.1. And remember, that is to the power 3. For methane, I've got 0.4. And for steam, I've got 0.3. All right. So you can put all of these values in your calculator. and you're going to get a Kc value of 0.00025. And remember, Kc is a ratio. It is the ratio of the concentration of the products to the concentration of the reactants. So it doesn't have a unit. So Kc value, we just can simply write it as 0.0025. That's our Kc. 6.5 is now asking us or telling us that the temperature is decreased, and how will this change affect the value of the Kc above, right? So we know, right, from our theory that the only thing that changes our Kc is temperature. So now we're trying to figure out what happened to our Kc. Did it increase? Did it decrease as a result of this decrease in temperature? So what do we know already? We know that temperature is decreased, and a decrease in temperature according to Le Chatelier's principle always favors the exothermic reaction. Beautiful. So now if I go back to my initial statement here, the exothermic reaction, we know, as we said earlier, it is the reverse reaction. All right, so the reverse reaction. So in the reverse reaction, what is happening? When the reverse reaction, the reaction is going to the left in this form, my products are decreasing. My products are decreasing. My products are being used up. So my carbon monoxide and hydrogen gas are being used up. So my products are decreasing. Why is this important? This is important because Kc is directly proportional to the concentration of your products. So what does that mean? That means if your products decrease, therefore your Kc will decrease. So to answer this question, when you decrease the temperature, it favors the exothermic reaction, and the exothermic reaction decreases the concentration of the products. When concentration of products decrease, therefore the Kc will decrease. So the answer to this question is decrease. Wonderful. Thank you so much for tuning in. Please make sure to subscribe and hit the notification bell as we post more videos. More videos will be coming, and I hope you enjoyed this one. I'll see you in the next one.